Hey all, and welcome to a new video. In this one we are going to talk about the jit.gl.node object, then we're going to talk about the jit.gl.pass, and then we're going to talk about the jit.gl.material. And we're going to demystify how those objects work. So why exactly these three objects? That's because they are all interconnected with each other. They do stuff that is used by the others to do other stuff. So let's start first with the jit.gl.material. So let's create a grid shape object which draws to my context, which is called the game. As you can see, is the name of my rendering context. I got a camera here that I can move using my keys on the keyboard. And I just created a jit.gl grid shape, which, as you can see, by default is the shape of a sphere. Let's actually make it white by assigning it the color 1. Great. Now I create a jit.gl.material, which also draws to the game rendering context. Great. Now, in GL3, what happens is that this jit.gl.material automatically creates a shader that modifies the appearance of this sphere. As you can see, in fact, it looks much different than before. So we can actually inspect the shader that is created by the jit.gl.material object by using the message get GL3 shader, and we send it not to the jit.gl.material but to the jit.gl grid shape. So if we click on it, we can see that this is the shader that has been automatically generated by the jit.gl.material. As you can see in the fragment shader section, which is the latest one, the final output is the jit.material.color, which is the sum of all the lighting calculations and colors applied to the object. So the output is here out color. We can also attach a diffuse texture to the jit.gl.material, which is going to simply change the color of the object. We can use a noise for that, for example. And now, as you can see, if I check again the shader has been modified in order to include that texture. As you can see, the first line here, there is a new parameter which is the diffuse texture has been attached. Before it was not there. The shader gets modified every time the jit.gl.material object changes, or a new light is inserted in the scene, or something modifies the appearance of the object. Great. So this is how the jit.gl.material works, right? We can even double click on it, and we can choose some different property for the material. So now let's go and see how the jit.gl.node actually works. So the jit.gl.node draws also to our main rendering context, which is called the game. And what it does is that it creates another rendering context to which our 3D objects can draw. So if I say the name of these objects, for example, I call it node, and I say capture 1, I give it capture 1 as an attribute. It means that now, instead of drawing the objects into the main rendering context, which is our rendering window here, I can actually draw them to our node. So if I draw this jit.gl grid shape to node instead of to game, you can see that this appears from the main window, because now it's being rendered inside this other rendering context, this other buffer, which is generated by the jit.gl node. So if I attach a jit.p window to the output of the jit node, that's a jit.p window, you can see that the sphere appears actually inside this window. I can still go around with the camera in the world, and it will still move the sphere around. Great. So now what we can do with that is that we have a buffer, so a texture that we can actually modify to change the appearance of what is being drawn in the window at the pixel level. So instead of drawing it into a jit.p window, we can draw it into a jit.gl video plane, which draws to game. So the jit.gl video plane draws to game. But instead of having it just as a three-dimensional object in the world, this video plane, I will change its transform reset to 2, which means this shape is going to occupy the wall screen. So it's now the same result as if we will drive the grid shape on the game rendering context, so on the main rendering context. But instead, I'm drawing into the node rendering context that outputs a texture that goes inside the jit.gl video plane, which then represents it on the screen. Great. So now we could modify the appearance of these or what is rendered by using, for example, a jit.gl pix object that modifies texture. We can, for example, multiply this by some color, and we will change the appearance of all the objects rendered in the scene. Let's actually create another object, another GGL grid shape. Let's place it a bit back in the scene, so position 0, 0, minus 10. Let me actually delete also this GGL node. So let's actually move this sphere at a position 0, 1, minus 10. So it's 10 units back on the zeta axis. Let's actually create also some kind of floor with another GGL grid shape that always draws 2 nodi, but this time the shape is going to be a plane, the scale is going to be 10, and I'm going to rotate it minus 90, 0, 0 in order to have some sort of plane. I'm also going to give it the poly mode 1, 1, so we have some sort of a plane. Okay, great. So this is all rendered inside our buffer created by the jit.gl node. As you can see, let's see it again. If I attach a jit.p window, I have the scene rendered inside this buffer. Great. Now, the jit.gl node is capturing with capture 1 the color of the scene. So it's capturing the color buffer of the scene, which just contains the color at the single pixels for all the scene. But I can also say capture 2, which then will make the jit.gl node output a couple of textures. The first texture is going to be the color buffer, but the second texture is going to be something different. So if I unpack that, so if I unpack these 3 symbols and do something like this, prepend jit.gl texture here and here. So let's see, if I connect the jit.gl video plane here, I should still have the color buffer. It's not working because of a temporary bug, I think, which every time I recreate the jit.gl node, I have to create all the objects that draw to it. That's kind of a temporary bug, but I guess it's going to be fixed soon. So as you can see, in the first texture that this object is outputting, we have the color buffer. So let's see what happens actually if we connect this to the second texture. Oh, as you can see, the second texture actually contains the normals of the objects in the scene, but only of the objects to which a jit.gl material is applied. Because if we now go to check the jit.gl3 shader, we can see that there's another output. It's called output color 2. So before there was only output color 1. Now that I set the node to capture 2, the shader has been automatically modified and now includes an output color 2, which exports in the first 3 planes the normals of the object, so the vectors that are needed to calculate the lighting on the object, and on the 4th plane it has the distance of this object from the camera. So if I will do something like this, I will get a jit.gl pix, which draws to node, and I will just switch the alpha channel. Now you can see that I'm seeing this is the distance, the linear distance of these objects from the camera. The brighter the color is, the farther it means those objects are, because the number is going to be bigger. The smaller the number is, the darker this color is going to be, right? Very cool. So if I instead switch only the RG and B, this is going to be the normals of the objects. Okay, amazing. Now, what happens when I create a jit.gl.pass? So let's do it. jit.gl.pass that draws to node, and I give it the fx name doff, so the depth of field effect. Now, I don't have to attach anymore the jit.gl video plane to the output of jit.gl node. I actually have to attach it to jit.gl.pass, because this is now my new output. The jit.gl.pass draws into takes the context of the node, so the jit.gl node object, and automatically sets its capture attribute in order to output all the inputs that the pass needs. For example, if we double click on the jit.gl.pass object, it's going to open it on an external editor, and we can see that it uses a bunch of shaders. So a jit.gl.pass is actually just a bunch of shaders, a bunch of pixel shaders, one after the other. So we can see that it's using the cf.gaussian.2p, and then it's using it 4 times, and then it's using as a final shader is the mrt.dof. But all those passes takes an input. So the first pass takes as input the color buffer. Now the color buffer is the same color buffer that is output from the GGL node as the first texture output. Alright, it's the same texture here. Let's actually visualize it with the JIT window. Right, this is our color buffer. So let's see what are the other requirements for this GGL pass. The other passes take as input the previous pass, which means the output from this shader here. So this takes the output from this shader here, this takes the output from the previous one, this from the previous one, this from the previous one as well. Now the latest shader actually takes 3 inputs. It takes as the first input the color, as the second input it takes the normals, and as the third input it takes the previous, which is the result from the previous shader. So the color is the same color buffer that was input in the first shader up here. The normals are exactly the normals that are output as the second buffer, so the second texture from the GGL node, and the third input, as we said, is the result from the previous pass. Great, so let's actually check this shader, mrt.dof. We can find it if we go in our file browser. We can look for it, just to see how it looks like. So mrt.depthoffield.jxs, I just double click on it, it opens it. As you can see, it has 3 texture inputs, and we know that also from the pass file. We know that it has the color input, a normal, and a previous. So we can see the first texture that comes in the shader is called text color, the second one is called text normals, and the third one is called text blur, because it's the blurred buffer that comes from these Gaussian filters, the result from the previous pass. So if this GGL pass didn't require the normals input, the shader created by the GGL material would have not generated it in automatically. Okay, this output color 2 will not be here, will only be out color 1. But since this GGL pass node requires these normals, the shader generates it. So I don't even have to specify it in the node what that I need to capture. Also the second buffer of the normals plus the distance is going to do it automatically once I have a GGL pass that has an effect that requires those buffers. Now let's just see this effect in action by changing, for example, the focal distance. As you can see, the floor is not being affected by that because it doesn't have a GGL material attached. That's why it's not generating. If we check its GL3 shader, which by default it has it as well, you can see that it's actually just outputting the color, so it's not outputting the normals and so on. So if we connect actually a GGL material to it, we lose the poly mode effect. This doesn't work anymore with the GGL material attached. By now, probably going to work in the future, but you can see that now the depth of field is working also on the floor. So now we can change the focal distance in order to have, for example, this object in focus and this not, or we can put this object not in focus and other in focus by moving it somewhere. Maybe we should actually first make the focal range a bit higher, like for example 30, and then we can change the focal distance in order to have also the second one in focus and the first one not. Right. As you can see, now we can also see the normals for the plane, since I have attached a GGL material to it. Right. So this is how the GGL pass and GGL node and GGL material interact with each other. The GGL material and GGL node are all necessary if we want to use a GGL pass, which creates post-processing effects, so it's very cool to use it most of the times. And this is how it works. I hope it was clear. If you have some questions, just hit me up here on YouTube or check my Patreon channel and join my Discord. See you soon in the next video, and in the meantime, have fun. Ciao.